AI actually solve its own heat problem? It's a crucial question, folks, because right now, chips running AI workloads are just running way too hot. And this isn't some minor engineering hiccup. We're talking about a massive environmental and economic bottleneck. We desperately need more efficient integrated circuits. We need materials that can handle the blistering thermal output of modern GPUs without taking a hit on performance. Because if we can't figure out how to cool these chips down at a fundamental material level, the entire AI revolution might just hit a brick wall called thermodynamics.
Section 1. The AI Solution and Pipeline. So to understand how we might actually fix this, let's look at a really fascinating startup called Discovered Materials. It was launched by two guys who perfectly bridge the gap between software and physical science. You've got Advais Sridhar on the software side. He has deep experience building AI agents, and Akash Ramdas, who holds a Stanford PhD in materials science. Together, they're tackling this heat paradox head-on by deploying literal swarms of AI agents to hunt down entirely new semiconductor materials. And hey, if you're wondering if the industry takes this seriously, well, they just closed a $9 million seed round. $9 million. And it wasn't just anyone. It was led by Lightspeed India partners, backed by Peak XV partners, and they just came straight out of Y Combinator. Plus, they've got heavyweight angels like Paul Graham and Gokul Lajaram on board. In the startup world, that kind of backing is a massive stamp of credibility. The smartest money in tech is betting that this exact intersection of AI and material science is the next big frontier.
Okay, let's dive into this pipeline, because this is where the magic really happens. How do you actually use AI to find a new physical material, right? Well, Discovered Materials built this custom software harness that works in 3 distinct steps. First, they use frontier models from Anthropic to generate potential material leads, basically brainstorming brand new molecular structures out of thin air. Then, for step 2, they take those leads and feed them into foundational physics models that they've specifically trained to run simulations. This verifies if these AI hallucinated materials actually, obey the laws of physics and have the right thermal properties. And finally, if the math checks out, it moves on to the critical validation stage.
And this right here perfectly illustrates why this AI-driven approach is a total game changer compared to traditional science. Just look at the contrast. Back when founder Akash Ramdas was grinding through his PhD at Stanford, working as hard as humanly possible, he was making, maybe 20 educated guesses a day about new materials. Today, their new setup uses AI agents running 24/7 in the cloud. These agents are firing off thousands of guesses every single day. The sheer volume of hypotheses being generated and tested digitally now, it's an absolute paradigm shift for material science.
Section 2. Playing atomic whack-a-mole.
Because, as you can imagine, it isn't as simple as just asking ChatGPT to find you a cold rock. We're stepping into what engineers call the trade space, and it is incredibly unforgiving. Finding a novel material that actually cools things down, that's just step 1. It also has to be physically manufacturable into a computer chip, and its electrical properties have to remain completely intact. Because if it cools well but doesn't conduct electricity properly, it's totally useless for a GPU. This crazy multidimensional conflict is captured perfectly by Hemant Mohapatra, the Lightspeed partner who led their seed round. He said it's a bit of playing whack-a-mole with atomic structures. I just love that phrasing because it hits the nail on the head. You solve one problem, boom, heat dissipation is fixed, and instantly another one pops up, like manufacturability. A material only matters in the real world if all these different physical and electrical traits line up perfectly at the exact same time.
Now, because this is a multi-billion-dollar headache, the space is definitely getting crowded. Discovered Materials isn't the only player on the board. You've got companies like MatNex, SandboxAQ, and Cusp AI, all launching these similar, highly funded efforts to discover materials using AI. But Discovered Materials is making a very specific bet to stand out from the pack. They're keeping a laser focus strictly on the thermal problems of semiconductors. They figure, hey, let's not try to solve every single material science problem on the planet. Let's just hunt for cooler chips. And they believe that specialization is going to be their winning edge.
Their business model is also incredibly straightforward. Their stated goal over the next year is to find these valuable candidates, patent the materials specifically for GPUs, or patent the process to manufacture them, and then just license those out to the big chip makers. And they're already making moves, too. The startup says they've already discovered several candidates that match the properties of materials currently used by major manufacturers. They've even released this material discovery bench to track how different frontier AI models stack up against this exact challenge.
Section 3. The physical bottleneck.
Now, what's really interesting about this slide is we need to take a step back and do a grounded reality check. The AI hype right now is deafening, right? But we have to look at the cold, hard facts on the ground.
Despite billions of dollars pouring in and thousands of AI guesses happening every day, we actually haven't seen any AI-discovered drugs or materials make a massive commercial impact at a global scale yet. There is this very real physical bottleneck that code alone just hasn't bypassed. Just look at where the industry actually sits today with these specific examples. In silico medicine's Rentrosib, it's widely celebrated as the first drug discovered with generative AI, but it's still only in phase 2 clinical trials. Over on the materials side, Matnex found these really promising rare earth-free permanent magnets, and giants like Panasonic alongside Citron Informatics have worked out new semiconductor materials. But again, none of these have been commercially deployed at scale. The software generation is moving at light speed, but real-world deployment, it's severely lagging behind.
And the reason for this delay is pretty fundamental. As these AI models just keep getting better and better, predicting a novel substance is going to become completely commoditized. Basically, anyone with enough compute will be able to guess a new atomic structure. The true bottleneck, the real, actual physical moat for any of these companies, is going to be filtering those candidates correctly and then actually synthesizing them in a physical wet lab. At the end of the day, you have to actually build the stuff to see if the AI was telling the truth.
And honestly, this is a reality that Discovered Materials' own founder, Advaith Sridhar, totally acknowledges. He says, a lot of this will involve actually going into wet labs and making things as well. And this is the process that cannot be sped up. I mean, it's so true. It doesn't matter how fast your cloud agents are running. It doesn't matter how brilliant your Anthropic prompt is. Eventually, a human being has to put on a pair of safety goggles, walk into a lab, mix some chemicals, and literally go bake a rock to test its physical properties. Making things in the real world permanently limits the speed of software. Which leaves us with this final, absolutely critical question to ponder. If code cannot speed up physical synthesis, how long is it really going to be until AI-discovered chips actually cool down our data centers? We are basically watching this massive race between the incredible exponential speed of AI software and the stubborn, methodical, and honestly pretty slow reality of hardware manufacturing. Discovered Materials is pushing the boundaries for sure, but the final test, that's not going to be won in the cloud. It's going to be won in the lab. Thank you so much for joining me for this explainer today, and I absolutely